This video is brought to you by Sailrite. Visit Sailrite.com for all your project supplies, tools, and instructions. In this video, we'll show you how to make shade sails. Shade sails are stylish, durable, and functional. They can instantly transform any outdoor area into an outdoor paradise as they protect you from the sun's UV. A beautiful addition to a patio, backyard, pool, and more. Simply said, they enhance the appeal of any property and provide a comfortable space for entertaining outdoors. Here, at our Sailrite facility, we installed 2 triangular shade sails, mainly to show you how easy it is to sew them up and install them yourself. Sailrite has the supplies you need and the instructional videos to walk you through the steps of building shade sails. Bill Becker from Sailrite is going to show us how to make shade sails. The first step is determining where the shade sails will be positioned. To aid in determining the desired size and location of your sail shade, we suggest using ropes and laying them over the exact area where you want the sail shade. We will be making 2 triangular sail shades. The sides of our sail shade will be 25 feet in length, so we've made a rope with each leg equaling 25 feet and knots at some of the corners. It is not uncommon to move the rope sides around several times until you are happy with the location and position of your sail shade. When determining the location of your sail shades, keep in mind the movement of the sun across the sky throughout the day. You will find websites that show you exactly where the sun will travel for your exact location. Here we are showing a website called suncalc.net. If you will be installing more than one sail shade, use another length of rope and position it too, leaving the first rope in place so you can see how the sail shades will look together. Make adjustments as desired until you have a pleasing look and the max coverage you desire. Each knot represents our sail shade's corner. To determine where our post will be placed, we must measure at least 18 inches away from the corner. If you will be using a 4-sided post, it's important that the flat face of that post be installed so that connectors will face towards the middle of the sail. This is easily accomplished simply by intersecting the opposite side of the sail's middle position, shown here by the yellow arrows. Here, Bill is using spray paint to determine the appropriate location for a post and to show the angle of one of the flat sides of the post. You can see that in this aerial view of our shade sails. Shade sails do not have straight lines at the edges. They are constructed with the gentle curve we call hollow. We usually use a 7% hollow on each side, which works great to help tension the sail's middle fabric and sides. A deeper hollow will reduce possible sag in the center of the sail, but will also reduce overall square footage, cutting down on the sail's sun coverage. The best looking installations have bold changes in height from one corner to the next, and they also have overlapping sails or multiple sails, giving them a more interesting look. Changes in elevations from corner to corner will provide a visually stunning look. These height changes may change from 3 to 6 feet per side, depending on the size of the sail. Here are some important notes that will answer most of your questions regarding a sail shade installation. These exact notes will also be posted in the description of the YouTube video. In these notes you will find some guidelines on how to install the posts. However, we will not be covering that in this video since there are a variety of ways to install posts. Next, we're going to show you how to loft the shade sail fabric. We make ordering supplies for a shade sail easy using Sailrite's fabric calculator. However, you first need to pick a shade fabric before you can use that calculator. To do this, visit Sailrite.com and click on Fabric by hovering over Shop by Department. Under Outdoor Living Fabric, click on Awning and Shade Fabric, then click on Shade Sails. Here you will see many possible fabrics that will work great for a shade sail. The most popular fabric for shade sails is called Polytex. Why? Because it's 150 inches wide. Here we're going to pick the aquamarine. You can see a close-up of the fabric, and you can also read about the specs of the fabric. Now that you know what type of material you're going to use for your shade sail and also the size of your shade sail, you can visit Sailrite's fabric calculator and enter the measurements into the calculator to determine the amount of fabric and the materials you will need. As you can see, the Sailrite fabric calculator accounts for a lot of different projects. We're going to click on sail shades. We're building a 3-sided sail shade, and each side finished is 25 feet or 300 inches. Typically, a 2-inch hem is always selected here. Our fabric width using the Polytex fabric is 150 inches. Now we can click the Calculate button and scroll down and see the estimated yardage required for our project. The calculator gives the size dimension for each side and also each side's hollow. It also gives you a materials list so that you know what items you need to purchase from Sailrite. The first drawing of the cut panel rendering shows the shade sail lofted together with each side's length before hems and also each seam, if any exist. Scroll down a little more and you'll see a second drawing. This drawing shows the scale rendition with panels running along the fabric's width horizontally and the length vertically. You can actually use this drawing to measure and strike lines and cut out your fabric. Before we explain how to use this drawing to cut your fabric, let's first show the traditional way to loft the fabric for a sail shade. We will come back to this scale drawing after that. In preparation for traditional lofting, we'll take the calculated measurements from the fabric calculator and then use tape measures to intersect the measurement at the corners. The lofting of a large sail is typically done on a driveway or parking lot or gym. Our finished sail is an equilateral triangle with 25-foot sides, so this driveway is a little too small, but it will still work. Since we can't drive stakes into the cement to draw our string taut, we're using cement blocks as anchors for our lofting dimensions. The use of sidewalk chalk will make it possible for us to know exactly where each corner should rest. Then we can draw our strings taut and place the corners exactly where we want them. Here you can see that one of our corners actually goes off into the grass because our driveway is just not big enough here, but it'll still work great. Our desired size is now lofted using the string on this driveway. We're now ready to lay out our fabric. The fabric that we're using is called Polytex. It's a shade cloth fabric that's 150 inches wide. Here it's folded in half. So we're going to unfold it here and lay it on top of our lines that we lofted onto the cement. Our desired size is 25 foot per side, and that requires us to use 2 panels. Here Bill is positioning the fabric over the lines to utilize the best cloth usage and also to lay it down as flat as possible over top of those lines. When he's satisfied with how it's nested over top of the strings, he'll use chalk and rub it over the string that's underneath the fabric. This places a beautiful line on the fabric without having to use any straight edges since the string is pulled taut and it's nice and straight. Once this is done, now Bill can pull the fabric away from the string and use scissors and cut it out. Pulling it away from the string will prevent us from accidentally cutting our lines. Once this has been cut out, we can concentrate on the top panel that needs to be joined to make our sail complete. In preparation for joining the top panel to this bottom panel, we need to create a 1-inch seam line. Here we're using the clear acrylic ruler and chalk and scribing a line 1 inch from the edge of that first panel along the top. Once the seam line is complete, we will reposition that panel over our string. We didn't show that. Then we will take the leftover fabric and roll it 180 degrees and pull it over the previous section we just lofted. Position it along the 1-inch seam line we just struck down and in such a way that it uses as little fabric as possible. This HDPE fabric has 2 distinctive looking sides, so be sure you do not flip this fabric as you nest more panels. Some fabrics are flippable, like Sunbrella or Fifertex Plus or Soltis. If you have questions about the fabric, be sure to give us a call at Sailrite. Since Bill's working alone, he's going to use spring clamps along the edge to help to position that fabric directly over the seam line. Once it's directly over the seam line, he can use his chalk here and trace over the line that's underneath the sail shade. That shows the traditional way to loft the shade sails panels. Now let's go back to the Sailrite fabric calculator. After entering all your measurements, we'll scroll down to that second drawing that shows the scale rendition. This drawing shows the panels nested on the fabric. The fabric has been rolled along its length vertically. So you would do the same with your fabric. The spot at the top is the 0-point measurement. Measure down to the next point. For us, it's 306.93 inches. Place a mark there. Then if we go to the right side, that's the 0 point at the top, and come down to the next measurement. Ours is 86.03. Then we go back to the top on the right side and to the next measurement. For us, 220.9. Now strike lines from those marked points. To do this, find the 0 point along the left side of the fabric and place a straight edge from it to the calculated point on the right side. Do the same with the mark on the left side to the mark on the right side. Since we're using a 150-inch wide fabric, you can use PVC pipe as a straight edge or string. Your first panel is now lofted. Now we'll do the same with any remaining panels. Measure down from the 0 point on the left down to that new measurement. Then measure over from the left edge of the fabric the amount calculated for the from left. This would be perpendicular from the edge of the fabric, and place a mark there. And the final measurement down the right side to the next mark. Mark it there. Then strike a line from point to point. Now we can cut out our fabric simply by following those lines we struck on our fabric. We already hinted to marking the seam line with chalk. Here we're going to show it one more time because we're going to get ready for basting. If your shade sail has more than one panel, you'll need to strike a seam line 1 inch down from the edge of probably the larger panel. Then the opposite panel can be lined up to that, basted together, and then sewn together. Here we're using the clear acrylic ruler to strike a line with our chalk 1 inch from the raw edge of that panel. We're going to seam the second panel to the first using seam stick for canvas. We'll place that seam stick in the middle of the area where we allow for the seam allowance. Then we'll use the Sailrite canvas patterning ruler to press the seam stick firmly to the fabric. This creates a flat surface and also helps to bond the glue to the fabric. Peel off the transfer paper of the seam stick and it reveals the glue. Now we can baste that top panel onto that second panel, following the seam line as our guide. Be sure the fabric is as flat as possible and do not pull on one panel more than the other. So try to apply consistent pressure as you baste the two halves together. This seam stick or basting tape will temporarily hold the panels in place as we take them to the sewing machine and sew them. It is not a permanent adhesive. It is just meant to be temporary to make sewing much easier. Here we're using the Sailrite canvas patterning ruler yet again to firmly press on the adhesive, bonding the two panels of fabric together as best as possible. In preparation for sewing, scroll the panel as neatly as possible. Here we're starting at the top of the sail shade and scrolling it all the way to the seam line. Using spring clamps will keep our roll from unrolling. We'll do that same procedure for the bottom side, scrolling the fabric up to our seam line. We'll fold both ends in, and then with the use of a second helper, we will roll this side as well. A second helper is required on sides that are long like this to keep the scroll as tight as possible. Now our shade sail is easy to transport to the sewing machine, and it's also easier to feed it through the throat of the sewing machine because it's scrolled up tightly. Depending on the size of your shade sail and the width of the fabric you have selected, you may or may not have any seams. We have one. Sail shades can be sewn with a polyester thread or a PTFE thread, which is a lifetime thread. Profilin brand thread works better than any other brand of PTFE thread that we've ever tested in an oscillating hook sewing machine, like the Ultra Feed sewing machine. This Polytex fabric is a high-density polyurethane fabric, so it's rather slippery. Because of that, we find that using a size 16 or 14 needle helps to prevent skip stitches when sewing with profilin thread. Those smaller needles make a smaller hole, so the thread can bind easily in the hole when it exits, thus creating a loop for the hook to catch. Enough about thread. Notice here that we're sewing about an 1/8 inch from the raw edge of the fabric, and we're sewing a straight stitch of about a 6mm stitch length. We're sewing down one side of this 1-inch seam. Then we'll sew down the opposite side, sewing about an 1/8 inch from the raw edge of the fabric there. There's no need to do any reversing at the beginning and the end. Why? Because we're going to create a hollow. Thus we're going to be cutting the edges of the sail shade down in size. So just sew along that edge, keeping the stitch as straight as possible. If you're using a PTFE thread with this HDPE fabric, you can expect a few skip stitches because it's so slippery. After all panels, if any, are sewn together, it's time to create hollow. Now we can lay our sail shade on a flat surface again. The perimeter of each sail is designed with a pleasing curve inward towards the center of the sail to control the fabric tension. Our shade sail will have reinforced webbing around the edges and marine stainless steel hardware at each corner. When properly tensioned, this curve, or hollow, helps eliminate fabric wrinkles, sagging, and even flapping in the heaviest of winds. Let's go back to the Sailrite fabric calculator and enter our dimensions. We recommend a hollow of about 7% or more per edge. The Sailrite fabric calculator can be used to look up the amount of hollow on each side of your sail shade. All of our sides are 300 inches. Let's change the last one to 200 inches as an example. Hit the recalculate, scroll down, and notice now we have 21 inches of hollow on two sides and 14 inches for the smaller side. To create a smooth hollow or curve, we will use 1/2 inch thin-walled PVC pipe and pipe connectors to extend the length of each 10-foot stick. This PVC is cheap and readily available at most hardware stores. We need to find the center of the side. So we've taken an overall measurement and divided it by 2, and then we use chalk here to find the center of that side. Find and mark the center for each side. Then take your PVC and lay it along that side. The hem allowance should be 2 inches. So at the corners, lay the PVC at the corner 2 inches up from the edge. Here we're using cement blocks to hold the PVC 2 inches up from the edge. At the center location, measure in your hollow allowance. For us, it's 21 inches. We mark it with the chalk and then move our PVC there. We can use another cement block to hold the PVC in place. Look down the PVC to make sure that you have a pleasing, nice curve that's gentle from corner to corner. What you see here in the video is a pleasing inward curve that'll work perfect. Once you're happy, use your chalk and mark along the PVC, being sure that you do not move the PVC so that that curve stays consistent down its entire length. Without a curve like this, you would find that the edges of your sail shade would flap in the wind, and the center would not be tensioned at all. So having a curve of 7% or more on each edge is very important. Follow this procedure for all of the sides. If using cement blocks, never drag a block on the fabric. Always lift it and reposition it. Remember, at the corners, our PVC pipe needs to be up 2 inches from the edge. We don't show measuring it, but we are 2 inches from the edge of the fabric at the corners. That allows for our 2-inch hem that we'll be taking in the next step. It may be a good idea to mark the 2-inch hem prior to moving the PVC to the next side. We didn't do that earlier, but we should have done it. Here we're using the Sailrite canvas patterning ruler with a Sharpie marker and marking so that the line is 2 inches from the PVC. This creates our 2-inch hem. Here's a side note. If anything, it's better to be slightly shy of 2 inches rather than more than 2 inches. After you've marked the edges of all of the sides, you can cut it with scissors. This will leave you some scrap fabric, and it will also reduce the square footage of the sail shade. Here you can see all the sides cut, with the chalk line being 2 inches in from the edge. Don't throw away that scrap fabric. We're going to use it to create corner patches next. At the center location on the fabric we just cut away for a hollow or curve, we will strike a line up diagonally, like what we are showing in the video. These diagonal lines should be larger than the actual sail's corner. They will be trimmed down later on. Here we're using a yardstick with a hole in the end, and we're creating an arc from the point or the intersection of the two diagonal lines. This creates a nice pie-shaped patch assembly. We only need one patch per corner, so we're going to cut this one out and transfer it to the next part of our scrap fabric that we cut out. We'll just trace along the cut lines that we made earlier with our Sharpie marker, and we'll cut that out as well. We need one patch per corner. The reason we only install one patch per sail corner is because the webbing will do most of the supporting of the sail shade, not the patch. Here you can see Bill using the chalk line and drawing new lines diagonally. This is the correct size of our patch. He also labels it A and A to indicate that that patch goes on this corner. Then he cuts on these new diagonal lines. This will make the patch fit that corner perfectly. Do that for all of the corners of your sail shade. Next, we need to work with the edging. Working with the sail shade on a small table or two like this is actually very easy. You do not need a large sewing spot to finish the edges and do the corners. Here we're applying seam stick for canvas 3/8 inch to each of the edges. Notice we are inside the edge by about a 1/2 inch to a 1/4 inch. We're doing that in an attempt to try to keep from sewing through the double-sided tape, which helps to prevent the glue from building up on the needle when sewing with the PTFE thread. This will help in preventing skip stitches. If you're not using a HDPE fabric like this Polytex, you don't have to worry necessarily about sewing through the seam stick. Most fabrics will clean the needle as the needle exits and enters the fabric. This fabric's rather slippery, so it doesn't clean the needle as well. The seam stick was basted to the side that does not have the chalk mark on it. This means when we fold it back to create the hem, we'll be able to see the chalk line and fold it along the chalk line. Using the Sailrite canvas patterning ruler as you baste creates a beautiful hemmed edge. The fabric scores nicely with a weighted object like the Sailrite canvas patterning ruler, and the basting tape holds it in place so you don't have to worry about it moving. Continue to baste carefully, making sure that your edge is nice and consistent. This edge will contain a hollow or inside curve. By using a couple tables like we're doing here in the video, we can baste a portion of the sail and then just simply move the sail along the tabletop, draping it over the two ends of the table. So working with a large sail is pretty easy with two tables like this. That raw edge of fabric in a future step, which we'll show here, will be covered by webbing. That's why we don't worry about the raw edge of the fabric being cut with a hot knife. We'll follow this procedure for all of the edges of our sail. Be sure not to cut any of the corners off at this time. We'll be using those to help protect the webbing as it wraps around our ring. We'll show that later on in the video. After all of the edges are hemmed back, about 2 inches or less, we can move on to the corner patches. The Polytex fabric has no right side and wrong side. However, it does have a side that looks different from the opposite. In an effort to keep everything looking the same, we want the patches to be installed so their side is facing the same side that they will be installed to. These patches will be installed to the side that we just created the hem on. Here along the bottom edge, the edge that is convex, we will install double-sided tape there and create a 1/2 inch hem. This will be the underside of the patch. Now we will take double-sided tape and baste it along the 2 diagonal sides and also the bottom convex side yet again. Be sure to use the correct patch with the correct corner of the sail. This one is labeled C, as you saw a little bit earlier on in the video. Remove the transfer paper, thus revealing the glue, and baste that patch to the appropriate corner. Baste it so that it is inside the folded hemmed edge slightly, by approximately an 1/8 inch or more. It will be covered up in webbing in the next step. Baste it on the same side that the hem was folded back to. The excess fabric going beyond the corner should not be cut off at this time. Do that for all of the corners, basting the patches in place. Here's corner B and B. When all the patches are in place, we can move on to installing the webbing around the perimeter. Sailrite stocks 2-inch polyester webbing that's great for shade sails. Next, we'll take our 2-inch polyester webbing and place the 3/8 inch basting tape right down the center of that polyester webbing. It sticks like gangbusters to this polyester webbing, so there's no need to use the Sailrite canvas patterning ruler for this. How much webbing do you need for your shade sail? Remember, the Sailrite fabric calculator tells you this. We will apply the webbing along each edge of our sail shade, extending past the corner by 12 inches at the corner patch we just installed. The basting tape on that 12-inch overhang is really not necessary and can be removed, but we'll just leave it in place for now. So we peeled off the transfer paper and will baste this webbing in place so there's about an 1/8 inch of the fold exposed. This 1/8 inch of shade fabric that is extending past the edge of the webbing will help hide the webbing from the sun. Polyester webbing does last quite a while in the sun, but protecting it will prolong its life. The 2-inch webbing also covers the raw edge of that cut fabric. That's why we didn't have to use a hot knife when we were cutting the hollow into the sail shade, because the raw edge is hidden by the webbing. As you can see, we don't need a huge work surface. As long as we have 2 fairly large tables like this, we can just pull the sail shade and work on the portion of the sail that is on top of the table. Once we reach the other corner, we will extend the webbing past that corner by 12 inches and cut it. We'll cut it with scissors, but it really should be cut with a hot knife, or at least touched up with a hot knife after this process. We didn't have a hot knife plugged in, so we're just going to measure over 12 inches from the corner of the patch and cut it with scissors. Later on, we'll touch this up with a hot knife to prevent the unraveling of the webbing. Only secure one side at a time, then sew. To sew the webbing in place, begin sewing about 2 inches down from the patch corner. Sew the outside edge first, keeping your stitch about an 1/8 inch from the edge of the webbing. We like to sew along one of the bar edges of the webbing. This makes a great guide for keeping the stitch as straight as possible. Do not worry if your stitch is not too straight, as it will not affect the overall strength of the stitch. We're using the Sailrite Ultrafeed sewing machine. This is the world's best portable walking foot sewing machine. That sewing machine is mounted in the Sailrite Ultrafeed collapsible sewing table. When reaching the other corner, stop about 2 inches from that corner. Do some reversing to lock your stitch in place, and you're done with that stitch. Next, we need to sew the other side of that webbing, or I should say the opposite inside edge. So we're going to feed it back into the sewing machine and sew about 2 inches from the corner, reversing at the beginning to lock the stitch in place, and we're going to sew in about an 1/8 inch inside the edge of that webbing there. Again, we're following the bar of the webbing to help keep our stitch as straight as possible. We did not use the magnetic guide. Later on, we remembered that we could use that to help keep our stitches nice and straight. We'll show that a little bit later on in the video. We'll need to follow this procedure, basting the webbing in place to all of the sides and sewing it in place, just as we did here in the video. Being sure to leave 12 inches of excess webbing hanging over the corner at that corner patch. Since we applied the basting tape to the entire length of our 2-inch webbing prior to installing each side, we need to remove the basting tape on the underside of this 12-inch extension past the corner. The side that Bill is pulling the double-sided tape from will actually be the exposed underside of our sail shade, so we need to remove all the basting tape there. Follow this same procedure for all the sides. We will not show more of this since it is exactly done in the same manner that we showed for the first side. Finally, we have our hot knife plugged in. So here at this 12-inch extension, we're going to use the Sailrite edge hot knife to cut the webbing. This seals the ends of the webbing and keeps it from unraveling. If you don't have a hot knife, you can use a wood-burning tool or a soldering gun. Then we'll sew on this side just as we did with the previous side. The sides of our sail are about 25 feet in length, not including the webbing, so there's a lot of sail to contend with. But as you can see, we can just drape the sail over the end of the table where the sewing machine is mounted, and the excess bulk can just sit beside the sewing machine. So again, you do not need a huge workspace to do this process. Before we move on, we want to show using the magnetic guide. We forgot to do this earlier, but this definitely helps to aid in keeping the stitch nice and straight, as it works like a table saw fence. Keeping the fabric up against it will keep that stitch in exactly the spot that you want it as you sew. Let's move on. Before we install our triangular ring or our D-ring with bar, we need to remove any excess seam stick that went over on top of our 12-inch extension. And if we have not cut it with a hot knife and used scissors, we need to trim the ends of the webbing with a hot knife to prevent the unraveling of the webbing. Now we'll apply basting tape on the top surface, the surface that's facing up, right in the middle of the webbing, going to our junction where the two webbing strips pass over each other. For our sail shades, we'll be using the Polyfab Pro Triangular. This is a 5/16 inch stainless steel triangular bar. We can use this for each of the corner applications. The 12 inches of extra webbing that extends past that corner should be folded to the opposite side and basted in place so it's directly on top of the webbing we sewed on the sides. Then the opposite 12-inch leg should be run through the ring and come down again on the opposite side of where it's installed, directly on top of the webbing we sewed down earlier. If done appropriately, you should see a little portion of the patch that you made earlier sticking past that corner. Simply peel it up and trim it so that it's about flush with the webbing, being sure that you do not cut through the webbing. That excess fabric hanging over the edge should be fed through the ring. It'll be used to help protect the corner of the webbing from the UV. However, there's plenty of fabric here to protect that corner, so we need to trim away some of it to make it easier to sew it. First, we're going to trim it so that it's about 1 inch to 2 inches past the bottom edge of the ring, so we can sew it easily to the sail. Then we're going to use that hot knife because it seals the edge of this HDPE fabric well and trim some of the excess bulk from this assembly. This will make it easier to sew through it and the multiple layers of webbing and patch and sail. Once it's folded back, you can't tell that any of it's been cut out, making it easier to sew through it. We've pulled away the shade fabric to reveal only the webbing, and we'll sew some straight stitches along the bottom of the stainless steel ring. We are sewing as close to the ring as possible. A roping zipper foot would even get us closer, but we did not install one here on the Sailrite Ultrafeed LS1 sewing machine. Sew back and forth about 4 times here. Next, we will secure the 12-inch flap of webbing by sewing it with several rows of a straight stitch. To make quick work of this, we will simply sew forward, then reverse down the length of the webbing. If you would like to be a little more detailed, you can sew several box X stitches, or try to sew each row with precision. The point here is to secure the webbing so it will hold up under a heavy load. Remember, your stitching will hardly be noticeable when the shade is installed, so you do not need to be extremely careful. Just get her done. For each leg we're sewing about 6 rows of a straight stitch down the entire length, doing reversing at the beginning and the end to lock our stitch in place. We'll do the same thing to the opposite 12-inch flap of webbing on the other side of this assembly. We will not show all of this, since the process is done in exactly the same way. Now we can take that flap of sail shade material and fold it back over the end of our stainless steel ring and webbing assembly, and we'll sew a few rows of a straight stitch here, tacking it down in place. This sail shade material at the end of our webbing will protect the webbing from being visible to the UV rays, prolonging its life. Last process is to sew the bottom edge of the patch assembly. We'll start here at the very edge of the sail, do some reversing, and sew over the webbing and very close to that hemmed edge of the patch assembly until we reach the other side, and we'll sew through the webbing and do some reversing there at the edge of the sail shade. Follow this same procedure for all of the corners of your sail shade. One sail shade has been installed already. We'll now install the one that we just sewed up. We already talked about the pleasing look you can achieve with changes in elevation from corner to corner. But it's also good to do this for water drainage. This is especially important for water-resistant fabrics, like Sunbrella. These height changes and mounting points may vary by as much as 3 foot per side. To determine where the second sail goes, here Bill is using a length of rope. He's attaching it to each post at an approximate height that he thinks will look good. This rope will allow him to see what the second sail will look like, atop or under the previous. If he likes the way it looks, he'll know exactly where to install the hardware for the attachment points. Before we can install that hardware, we need to make sure the second shade does not come too close to our first shade. We want to ensure that the second shade is at least 12 inches from the first shade when it's pulled taut. By using this rope, we can see the changes in elevations from corner to corner, and we are assured that the second sail shade will not be too close to the first. Here, Bill is laying out the second sail shade in an effort to determine where it will crisscross over the first. Using the blue sail on the ground, he can see where it will cross over the tan sail. At that location, he can measure the distance from the rope to the tan sail. If it's 12 inches or more, it's an acceptable spacing between the two sails. Bill has decided to lower the rope at this corner for a more drastic change in elevation from corner to corner. After fixing the rope to its post, he will check it again to be sure that all looks good before he drills and installs the attachment points that are made from stainless steel. Bill's happy with the location of the second sail, so he uses a pencil and marks the center of the post for each location where the hardware needs to be installed. The rope that we use to determine where the hardware needs to be installed can now be removed from our posts. We'll be using an eye bolt with nut and washer that's 3/8 inch or 10 millimeters. So we're drilling through our 6x6 post with a 3/8 inch drill bit. We'll drill all the way through this post. The actual size of a 6x6 wood post is actually 5.5 inches by 5.5 inches. The threaded post of our eye bolt needs to be at least 5 3/4 inches long. We can now drive it into the hole we just created in the post. As a general rule, you can use these calculations to figure the maximum load expected for the sail shade that you're building. To find the square footage of your particular sail shade, enter your measurements into the Sailrite fabric calculator. The square footage is listed right here. Sailrite also carries stainless steel lag eye screws. Be sure to check them out at Sailrite.com. They're great for fascia installations, tree installations, and more. Now we can install a washer and a nut on the back side of this threaded post. We'll follow this same procedure for all of our posts at the locations that we marked on the posts. Another option for installing hardware to the posts is to use the diamond pad eyes that are available from Sailrite. You can also use the diamond pad eye for existing structures like concrete, brick, or wood. Or, if you have a corner application, you can use the corner brackets. They too are great for concrete, brick, and wood applications. Now that our eyes have been installed to our structures, we're ready to start working with the stainless steel tensioning hardware. That's coming up in the next chapter. Our posts have been tilted back about 10 degrees. The slightly tilted posts will negate some of the weight of the sail when it's fully tensioned. If the posts were installed perfectly vertically, they may slightly bend inward towards the center of the sail. This would be completely obvious if the posts were vertical, but since they're slanted back, it will not be as obvious. It's not uncommon for the sail's corner to be too far from the post's hardware, even after the turnbuckles are added. Because of this, we like to use a 5/16 inch coil chain that is zinc plated. This chain can be purchased from a local hardware store. This chain will span the distance from the sail shade's corner to the attachment points. You will have to use bolt cutters to cut this chain. We will now use stainless steel turnbuckles, jaw and jaw, with nuts. Ours are 3/8 inch. Check out the large selection of turnbuckles at Sailrite.com. Because these turnbuckles from Sailrite are jaw-to-jaw turnbuckles, we can use those and attach them directly to the 5/16 inch coil chain that we purchased from a hardware store. The length of chain that we attached to this turnbuckle is a little bit longer than what we expect to use. The great thing about using a chain is you can attach to a specific link, and then if you have extra chain, just simply cut it off. Attaching a rope to the sail's corner will make it easy to pull it up over the tan sail shade to the post's attachment point. Now Bill can take the turnbuckle with the chain attached and attach the jaw of the turnbuckle to the eye bolt. To attach the corner of the sail shade to the chain, we're going to use a shackle with bolt. These shackles are purchased from Sailrite. You could also use what's called a quick link. We're not sure exactly which chain length will result in a perfect fit. We're going to attach it to the end of the shade here and then attach all the other corners before we tighten down any of the hardware. Notice the turnbuckle has been expanded to its maximum length. We want to do that for all of the turnbuckles for our sail shade. For a triangular sail shade, one with 3 sides, we recommend at least 2 turnbuckles. For a 4-sided sail shade, we recommend 3 turnbuckles. Using a turnbuckle at all corners would give you more tensioning ability, but it's typically not required. Here, we cannot reach the shackle. To help tension the sail to enable us to be able to attach the corner ring to the shackle, we will use a rope and create a 3-to-1 mechanical advantage, so we can hopefully pull on the rope to pull the corner to the shackle attachment point. To accomplish this, just tie the rope off to the eye, feed it through the corner ring, back through the eye, then through the corner ring. And then we can use it to pull the sail's corner closer to the shackle. In lieu of this, you could just use a ratcheting strap, which is typically webbing with the ratcheting device. It has 2 hooks, so you can hook it to the sail and the eye, and then pull the sail taut so the shackle can be attached to the corner ring. Here, if we had a second helper, he wouldn't have to tie the rope off, but since we have no one else to help, he's going to create a knot here, being sure that his turnbuckle and chain is on top of the loop that creates the knot. If a second helper were available, all he'd have to do is pull on the line as the helper attaches the shackle to the corner. When installing your sail shade, be sure that the webbing that has been attached around the perimeter of the sides is facing down, so that it is not exposed to the sun. Here it looks like it's facing up, but when we attach the third corner, you'll notice it is facing down. Bill confidently tightens the bolt on the shackle. You may want to hold this off until the end, in case you want to make modifications to its position. Now remove the 3-to-1 purchase. To do this, you may find that the rope may be bound in the stainless steel hardware, but with a good tug, you should be able to remove the rope from the stainless steel hardware. We have not yet tensioned the turnbuckle. We'll do that later on after all 3 corners are attached to their attachment points. The rope is used here on the last corner of the sail, and Bill ties a bowline knot. This rope will be used to pull it up to the last attachment point. Here on this post, 2 sail shades are attached, so we're using the shackles here with a length of the 5/16 inch coil chain, zinc plated. We'll use this length of rope and pull the corner up to our attachment point, creating our 3-to-1 mechanical advantage, just as we did earlier. When Bill's tensioning on the sail here, if he had a second helper, that second helper could attach the shackle to the corner of the sail. But since he does not have a second helper, he will tie a knot. After determining the length of chain that he needs, he pushes the other chain length away so that the shackle can go in the end of the chain, as shown here. Then attaches the bolt. Removing the rope that we used to tension the corner to the attachment point can be rather cumbersome, but a good tug will typically release it from any stainless steel that's binding the rope. This third corner does not have a turnbuckle, so we just used 2 shackles and a length of chain. Since this single post has 2 sail shades attached to it, and they're fairly large, we will attach a guy wire. We will show that process in one of the next chapters. This guy wire will help support the stress that's placed on this wooden 6x6 post. Stainless steel or other alloys, such as aluminum, may seize when they come under great tension. That is the case for these stainless steel turnbuckles, and in an effort to prevent them from binding or galling, we're going to use an anti-seize compound on the threads. Now that we have placed an anti-seize compound on the threads, we can begin to tension the turnbuckles, removing wrinkles and slack from our sail shades. We want to do this in successive order. So here at the second turnbuckle, we'll apply the anti-seize and start tensioning it, going back to the first after we have a little bit of tension on it. Move back and forth from one turnbuckle to the other, tightening it up as you go, and then inspect your sail. Tighten up the turnbuckles until there's very few or no wrinkles and there is no slack in the sails. Stop once that is achieved. A properly mounted and tensioned shade sail will have approximately 150 to 400 pounds of tension on it, and it will have few to no wrinkles. Wind loads from 5 to 15 pounds per square foot of sail size are typically expected. These loads are divided between the corners. Once you're happy with the sail, you can cut off excess chain, if any. Shade sails should be removed prior to any extreme weather conditions. An example is hurricane force winds. And shade sails are not intended to support snow loads. Remove shade sails if snow is expected. Once you're happy with the tensioning of your shade sails, be sure to tighten the nuts beside each turnbuckle. Our shade sail is now complete. However, we're going to install a guy wire on the post that accommodates the two sail shades. This will strengthen the post and keep it from possibly leaning forward too much. That's coming up next. If a single post is holding more than one large sail shade, they should have a large footing and be buried on the conservative side of 1/3 in the ground and 2/3 above. For additional support and peace of mind, you may choose to use a guy wire. This reinforces the post and also provides extra strength. Here's the base of a post with a single sail shade on it. It has hardly moved. But here's the post with two sail shades on it, and you'll notice it has a fairly substantial gap in the back. To keep this from getting worse, we're going to install a guy wire. If we'd installed the guy wire first before we installed the second shade, this probably would not have happened. To anchor our guy wire, we will use a 36-inch penetrator from American Earth Anchors. We will feed the tie-off cable onto the penetrator. Then, using a 2-inch socket with impact wrench, we will drive the earth anchor into the ground. The guy wire should extend out from the post at approximately a 45-degree angle. We'll show two ways to install this penetrator. First, we're going to use an impact wrench with the 2-inch socket. Using this rather small impact wrench, it's taking a little bit longer than what we'd like. When we get halfway, we decide to use an alternative method, which works actually fairly well. The deeper the anchor goes, the slower the impact wrench drives it in. We're going to remove the 2-inch socket and install it on a 1/2-inch ratcheting wrench. Without leverage, this is nearly impossible. But if we take a steel pipe and insert it on the end of the ratcheting wrench, it's fairly easy to do. And it's much quicker. If you visit the American Earth Anchors website, you'll notice that they recommend using an impact wrench, or a hydraulic installer, or a power takeoff tool. But for this 36-inch penetrator, you can see that a ratcheting wrench with a pipe actually works pretty well. That's all it takes to install the 36-inch penetrator from American Earth Anchors. We will now install another eye bolt with washer and nut near the top of our post. When we were installing the sail shades, we used shackles and bolts. Now we're going to use the quick link. The quick link is also a great way to attach hardware to other pieces of hardware. For this guy wire, we're going to use a thimble, wire rope and create an eye, and cinch off the eye with a wire rope clamp. We purchased a 3/16-inch galvanized wire rope from a hardware store. We will feed our wire rope clamps, 2 of them, onto the wire, then fold the end of the cable, creating an eye. We will feed the dead end of the wire rope through the wire rope clamp so the U-bolt side is over the dead end of the wire rope. Now we'll cinch up the eye, closing it, and before closing it completely, push in our thimble. This is a stainless steel thimble available from Sailrite. Then we'll tighten up our wire rope clamps. Begin by tightening the clamp closest to the eye. Once that clamp is in place, if your other wire rope clamp has slid down, slide it back into position. Be sure the U-bolt is over the dead end of the cable. Then tighten the nuts there as well. Now we can take our quick link and attach the eye to the eye bolt we just installed at the top of our post. To close the quick link, simply screw the nut closing the gate. Then, using a wrench and another tool to keep the quick link from turning, you can close it down and lock it hard. To tension our guy wire, we're going to use a turnbuckle. This is an eye-to-eye turnbuckle with nuts. Extend the turnbuckle to its maximum length, then apply the anti-seize to the threads, as we did earlier with the sail shade turnbuckles. This will help it from seizing up under high loads. Before assembling the guy wire at the ground, we're going to slide on a yellow piece of vinyl material. We made this from a naugahyde vinyl. We simply cut a 2 1/4 inch strip of naugahyde, folded it in half, and then sewed down the length of the naugahyde, reversing at the beginning and the end. And that's all we did. This brightly colored sleeve will hopefully alert others to the presence of the guy wire. If you like to save money and don't want to purchase a shackle or a quick link, you may want to take your thimble and simply use 2 channel lock pliers and pry the end of the thimble open so that you can install your other hardware inside the thimble without the use of a shackle or a quick link. This can be done at the top of the post and also where the turnbuckle attaches to the wire, but it cannot be done at the tie-off that attaches to the penetrator. There, you will have to use a quick link or a shackle. Once our turnbuckle with eye has been fed into the thimble, we can rebend it back into shape again using the channel locks. Now we'll use a quick link and attach it to the opposite end of the turnbuckle, and then attach that to the tie-off of the penetrator. Now we can take the wire rope and create yet another eye. We're going to use the wire rope clamps yet again in the same manner as we did before. We will have excess length in cable here because we want to cinch up the cable to as short a span as possible to include all of the hardware, and then we'll use the turnbuckle to do the tensioning. We will not cut off the excess length of cable, mainly because it's not too long, and we can feed the excess cable up into the sleeve that indicates there's a guide wire there, so people hopefully don't run into it. Cinch up the wire rope clamps in the same manner that you did earlier. Anti-seize compound has already been placed on the threaded bolts of the turnbuckle. Now we can cinch it down. Once you're happy with the tension, be sure that the nuts are drawn up tight to the body of the turnbuckle. We did not do that yet. Our shade sails installation is now complete. Coming up next, we'll show you the materials list and the tools that we used to make and install our shade sails. You will find a variety of fabric and stainless steel hardware choices for shade sails at Sailrite's website. Shown in yellow here, you see the quantity of materials that we used to make only one shade sail, the blue one. The tools we used are also shown. Notice the tools shown in blue here are not sold at Sailrite, but can be purchased at a hardware store if you don't own them already. We've also included a materials list for the guy wire, if that's something you want to implement in your shade sail design. If you have any questions about the materials or hardware that you need to order for your shade sail, be sure to give us a call at Sailrite or email us. We're glad to help. For more free videos like this, be sure to check out the Sailrite website or subscribe to the Sailrite YouTube channel. I'm Eric Grant, and from all of us here at Sailrite, thanks for watching.